Okay, so today we are covering section 5.3, 5.5, and 5.6 in the Green Book. Please make sure you write down the page numbers. In the Jupiter grades, I had to put it under 2 assignments because I couldn't put it all on one line. Okay? Okay, so the first thing we're going to talk about is multiplying and dividing monomials. So if we're talking about multiplying and dividing monomials, does anybody know what a monomial is? Monomial. Boop, boop, ba-doo-doo. Go on. Monomial. Do, 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 do. Go on.
Where's that from?
Muppets.
Is it the Muppets? Monomial. Do, 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 do. Mana. But I will give credit to this song for Kiyomi Morrison, who made that up probably like 5 years ago. She came to class and started singing that, and I've been singing it ever since. Okay, go, Irene.
So it's basically like a term with one, can't really express it, but it's not one term, is it?
It's one term. That's exactly what it is. And what is a term? It is a single term is a group of numbers and or variables. You should be writing this down. Tied together by multiplication or division, but separated by addition or subtraction. So it is a term that is tied together by addition and subtraction. Tied together by multiplication and division, but separated by addition and subtraction. Another thing you need to know is that you should have a whole number exponents. So, whole number exponents, so add that to your, can only have whole number exponents. Okay. Some examples would be negative 5x. 3x squared y. 4/3 a squared. Negative 5ab squared c over 2xy. And xy squared. So these are all monomials. Pause the recording if you need to write. Take notes. Can anybody tell me what a coefficient is? Coefficient. Hershey.
It is the number that goes in front of the variable, or is what the variable is multiplied by.
Okay, it's what precedes the variable, that comes before the variable. So our coefficient is what precedes the variable. And we also want to add that to our definition. Remember, whole number exponents. If it's a monomial. All right. So what are the coefficients of what is the coefficient of the first term, please? Yes.
Negative 5.
-5. And what is the coefficient of the next term, please? Preston. 3. Positive 3. And what is the coefficient of the next term? Eric.
4/3.
4/3 is correct. And what is the coefficient of the next term, Jack?
Negative 5 and 2.
Negative 5 over 2, not and 2. Over 2. And then the last one, let's go with Moreno. 1. That invisible 1 is our coefficient. So new words, monomial and coefficient. Questions? Okay. All right, moving on. So number 1, is it a monomial? The question is, state whether the following is a monomial or not. Number 1, Shaylin, is it a monomial?
Yes.
Yes, it is. Why?
This is a single term.
It's a single term, and it's a number and or variable. It doesn't have to be both. It has to be one or the other. Or it could be both tied together by multiplication. Number 2, is it a monomial?
No.
Okay, can anybody think about what this might be called? Let's go with Jack.
A binomial.
A binomial. Bi means 2. Bi means 2, and there's 2 terms, so it's a binomial, but it is not a monomial. Number 3. Number 3, let's go with Ryan. It is a monomial. And number 4, Michael.
Yes, it's in monomial.
Okay, number 5. Number 5. Let's go with, how about Armene?
It's not. It's a monomial.
It is a monomial. It's tied together by division. And number 6, Jake? Jacob?
Okay, me. Okay. No, it's not because there's subtraction and addition.
How many terms?
1, 2, 3.
There's 3 terms. What do you think we call that, Priscilla?
Trinomial.
Yep. Trinomial. You will be sleeping, eating, and breathing. Trinomials. Okay, number 7. Number 7, let's go with Luca.
No, it's not.
It's not a monomial.
Oh, it is.
It is a monomial because it is one term. It can be a number or variable. And number 8, let's go with Teddy. It is a monomial. Is number 8 a monomial? Annabelle?
No, it is not. Because
Why?
its exponent is not a whole number.
The exponent is not a whole number. Okay? Okay, questions. Moving on. Okay, today we are multiplying monomials, and we will add different layers. So, with the first one, I don't mind if you go right to the answer. Priscilla, what would that be?
-6
Mm-hmm.
A to the 4th.
A to the 4th. So we're multiplying coefficient with coefficient, and when we multiply like bases, we will actually add the exponents. -6, A to the 4th. Number 2, what would you get with that, Ethan Howard?
On number 2,
Mm-hmm.
we would get 15x to the 4th power.
Be careful what exponent is here.
3x.
To the what?
Oh, to the first power.
Right, if it's not written, it's to the first power. So what would it be?
Maybe 3x plus 5x to the 4th.
Okay, what am I doing? Not plus. There's no plus.
Multiplying.
What am I?
Right, so it'd be 3x times 5x to the 4th.
Right. And now what am I multiplying together?
Oh, and then you get 15x to the 4th power. Yeah,
No.
15.
You're close. Okay, coefficient with coefficient. What does it make?
It makes,
What am I multiplying?
You're multiplying the number in the.
What number specific? What am I doing?
5.
3 times 5. Coefficient with coefficient. Okay? What am I doing for my exponents?
X plus x to the 4th power. So the x
I don't-
to the 5th power.
Okay, that's not what we do. We don't do x plus x to the 4th. We use the exponents only. The first power plus the 4th power. It is only that part that we are adding, the exponents. Okay, we add the exponents when multiplying monomials. Okay, so what does it become?
3 times 5 times.
Give me it all together.
What do you mean?
Simplify it.
15 times x.
I don't need times. 15 what? What is the monomial?
15x to the 5th power.
Perfect. Okay, let's try the next one. What's getting multiplied, Ethan?
-4, 3, and -1.
Good. And then what about for the variables? What am I doing?
Do m plus 2,
M to the
m to the 2nd plus 4
second power plus the
plus the 4th power
plus the.
plus the 1st power.
Good. And what is it simplified to?
So 12 times m to the 7th power.
And I don't need you to say times m. When it's next to it means times.
Okay.
12 m to the 7th power. You guys got it? Okay. Armene, you clear? Okay, so let's try another. Why don't you guys do number 4? Pause the recording. Do number 4. Preston, what is number 4 going to be?
Do you want me to say the full answer?
You can just give me the answer, yes.
21a to the 5th power, b to the third power, c to the fourth power.
Perfect. Questions? Okay, so checking your work. All right, now we're adding a little layer. Now the layer, it may look like this is the same, but we're adding a more difficult layer. So I would like you to simplify each term first before you go right to the answer. Okay, Teddy, you with me? Thank you. All right, so what does this simplify to? What does this simplify to? Yes.
5y to the 6.
5y to the 6. Be careful. What are you missing, Hershey?
5 squared, 25y to the 6.
Right, so this, you can go right to 5 squared or 25. You don't need to do 5 squared, but remember, we have to take, everything is to the second power in there. So that's 5 squared and y to the third times the second power. When it's outside, inside, it means multiplication. And then what does this really mean? Annabella?
It means 4y.
Give me this second step.
Well, it means -2 squared y to
Y squared times the second power. Okay? Now you can simplify this. What does it become, Nomi?
25y to the 6th power
Good.
times -4y to the 4th power.
Are you sure negative 4?
4y.
4y to the 4th. Now what? Am I done? Okay, how about Jessica? Coefficients with coefficient, like base with like base.
Alright, so 100
Uh-huh.
and y to the 24th.
Okay, be careful. Remember, we multiply coefficients. When multiplying like bases, we really do what with the exponents?
Add them.
We add them. So it's going to be what?
10.
Right, so the whole thing's going to be?
100y to the 10th power.
Are you guys clear on that? Okay, try number 2. Pause the recording, try number 2. Okay, I'm okay with you skipping the second step, but you must do the third and the fourth step. Pause the recording.
Multiply the 3 to the second power.
Good, and that would be?
9.
This 9c, tell me what this,
9c to the second power
good,
times -8c to the 12th power.
perfect. Right, this is what she got. Now what would we do?
So then you would multiply 9 times -8, then c to the second power plus 12,
What's the 12th power, and that is?
-7c to the 14th power.
Good. Okay, questions? All right, you guys feel okay about this? We're going to skip the negative exponents because we don't really need it right now. We will come back to it, however. Give me a minute. I might do this one problem with you. Let's look at this. So I like this problem because my method that I was showing you the other day, as opposed to doing the subtraction with the exponents, tends to work better in something like this. Now remember, oops, I just break it off into 2 different problems, really. I handle it separately. Okay? So, what do I need to do to simplify the numerical part of it? Yes, Moreno.
Divide both numbers by 3.
Yeah, I can divide a common factor of 3 out, and what am I left with in the numerator? 2. And what am I left with in the denominator?
3.
A 3. And now, what is the greatest possible amount of m's we can divide out of the numerator and denominator? Greatest amount that they both contain. Shaylin? 4, m to the fourth. So when I divide m to the fourth by m to the fourth, what's left?
1.
The number 1. When I divide m to the 12th by m to the fourth, or take out 4, I'm really just taking 4 out as I cross cancel them through. What are we left with?
3. To the m to the third power?
No. If I have m, think of it like this. I have how many in the bottom?
You have 12 in the bottom.
Okay. And then how many in the top?
4.
When I do my cross canceling, what's going to end up being left?
M to the 8th power.
Right. So I'm just trying to get you, so look, really I'm just subtracting them out. So I'm left with m to the 8th. Okay? But what this does is it leaves me ready for my new fraction. There's 2. And in the denominator I have 3m to the 8th. Another way I could have done it is I could have taken 6 over 9 and then done m to the 4th top minus the bottom. Right? I know this becomes 2 over 3. And this is going to become what? So we know it becomes 2 over 3. And it's m to the negative 8th. Now, if it's m to the negative 8th, how would I write that as a positive fraction? I mean, as a positive exponent. Shaylin.
Well, just the exponent would be 1 over m to the 8th power.
Right, and so where would it go? I'm going to have what in my numerator?
2.
2 over 3 m to the 8th. Do you remember that? I just feel like this is too many steps here. You know what I mean? Whereas the cross canceling, you see where everything ends up. Okay, moving on. That's not going to be really much of our homework. Well, there'll be a little bit on that. Okay, now, we're going to skip the negative exponents. We are moving on to our second section, which is monomial. Monomial. Sorry. Have to do it. Okay, monomial. We said that it is single term consisting of numbers, variables, and whole number exponents. Okay? Now, if a monomial is a single term, what is a polynomial? Ryan? It's a sequence of terms. Another word for it would be?
It's just like the basic generalization for all of them.
It means many terms. Poly means many, as in polytheism, the belief in many gods. Polynomial, many terms. Okay? And within an expression with many terms, it's an expression consisting of 2 or more monomial terms that can't be combined. That means, what I want to know is, what would this mean? What is this? Know me? Huh?
8.
Well, is this a polynomial or is it a monomial?
It's well, because no, but it has a plus sign, so it can't be a monomial.
There should be a binomial because it consists of more than one. It consists of 2 terms that they can be combined.
Okay, let me go a little bit further and then we'll come back to this. So I'm going to write it down on my iPad. I just realized I didn't write it for everybody to see. So within the polynomial family, there are special terms. In the polynomial umbrella, the family, we have a 2 term would be a binomial. And 3 terms would be a trinomial. So the question was, that I put up, what would this be? Some people said it would be some people said it would be a binomial. Others said it. Yes.
I think it's a monomial because a polynomial is an expression consisting of two or more terms that cannot be combined.
Cannot be combined. Can these be combined?
Yes.
It can be simplified to 8x. And so that is really one term. These, they are unlike terms, and these are like terms. So if they're like terms, they can be simplified down to a monomial. Questions? All right, so now we are moving on. Does everybody get the idea? Can I move on?
Yep.
Oh, it's not changing because I'm in print mode. Okay, so now we are defining whether this is a monomial, binomial, trinomial, or poly. Sometimes more than one apply. So Michael, what about number 1?
It's a polynomial.
It's a polynomial, and anything else? What kind of binomial? Good. What about number 2, please? 1.
For number 2, it is a trinomial
And it is a...
and it is a polynomial.
Good. Number 3. Preston?
A monomial?
A monomial. And it is, that's it. Number 4. You guys get the idea? Let's move on, okay? Okay, questions? Okay. Next one. Now it's asking us to tell whether it's a polynomial, state the number of terms and the coefficient of the coefficient of the terms. So, is this a polynomial? Yes or no?
Yes.
Yes, it is. Okay. How many terms, Shaylin? 3 terms. What are the coefficients, please?
1, -3, and 8.
Just 1 and -3. What we call 8 is a constant term. Now, really, I've seen it written in books different ways that 8 sometimes is considered a coefficient, but we're not going to consider it. We're going to just call it because it would be the coefficient of x to the 0 power. But for our purposes, we're just going to call it a constant term. It is not a coefficient. Yes.
So in the homework, it's just considered a constant.
Correct. Okay, number 2. Is it a polynomial? Everyone.
Yeah.
How many terms? Everyone.
3.
Okay, and what is the coefficient of the first one? Everybody.
5.
Second one.
1.
And third one?
8.
Good. Is this a polynomial? No. Okay. I'm going to skip that one. How many terms, though, do we have?
4.
And notice, we only have 3 coefficients. 7, -1, and -4. Yes.
What? I'm just confused on what makes it a polynomial.
Many terms.
Oh.
Many terms. More than one term. Okay. Now, is this a polynomial? This is trick because I didn't give you a full definition. Well, no, I did. I did give you a full definition. Is this a monomial?
No.
I'm sorry, is it a polynomial?
Yeah.
What was the definition? Yes, for a polynomial.
An expression consisting of 2 or more monomial terms that cannot be combined.
And must have whole number exponents. Is this going to be a whole number exponent? It would be t to the -2 power to put it in that denominator. Remember, our negative exponents are really just fractions. Do not do that right now. Okay? Get your book out. Okay? Now, remember what I said. T being in the denominator is not a polynomial, because that would really be, if I wrote that with not in fraction form, it would be t to the -2 power. I could write this term as 4t to the -2, right? -2 power minus 3. So it is not a polynomial. Is this one a polynomial?
Yes.
Yes.
Yes, it's not a negative exponent, so it would be. And my coefficient would be 1/3. There's 2 terms. Is that clear? All right, standard form of the polynomials. Is everybody clear on that? What is standard form? Irene.
Standard form is when it's not ordered in descending form of exponents.
It is descending form of the exponents from highest to greatest number. It's when you put the terms in order of the exponents from the biggest exponent term to the smallest. So this would be non-standard form. And this would be me putting it, what's the biggest exponent in all of these terms? Luca? 5. So I would write that term first. Set positive 7x to the 5th. You always write this in standard form unless they ask differently. The next one would be, Teddy? Come on, guys. Nomi? I need the term, please. Right, negative x to the 4th power. Okay? We're going negative x to the 4th power. The next one, positive 4x squared. The next one, negative 3x to the 1st power. And then we have 8 because it's 8x to the 0 power, and we don't write that. Now, notice it goes 5, 4, 3, 2, 2, 1, and then our constant term. So when we state our polynomials, we always put it from the highest exponent first down. Questions? Yes?
When you have 2 of these same polynomials,
They get combined. Okay? So here I would just do this term, then this. If I were putting it into standard form. Are you guys seeing what we do? Okay, let me move on. Now, when we simplify, when you combine your like terms, we always start with the biggest exponent first. Okay? The biggest exponent first. So I start with my 3x to the 4th, and I add 7x to the 4th. How many x to the 4th does that make? 10x to the 4th, and it's positive. Then I'm doing negative 2x squared. Oh, the next one would be to the 3rd power. There's no 3rd power. So I'm combining negative 2x squared plus 3x squared makes how many x squareds? Yes. 1x squared. Do you understand how I'm doing this? Yes, no. Thumbs up, I understand. Thumbs down, I don't. Is there anything, what would be the next order, Shaylin? Is there anything to combine? No. What's the next order for the exponent? We've got 2. What would be next? The 1st power. What is to the 1st power? Which exponent shows the 1st power? Is it this one? Is it this one?
5x.
Yep. If it's not written, it's to the 1st power. And then last but not least, we always place our constants. Okay? So we're always placing them in order of the exponents from biggest to smallest. Now, does everybody understand that? Yes.
What if there were 2 different different variables with the same exponent?
They get combined.
Yeah, but they'd be different variables.
Okay, so like this one, hold on. Let me go down. You will get this here. I'm almost done, guys. I know it seems like we're doing the 3rd lesson here. So, couple different words that you're going to be hearing. Descending means we go down, right? That means from high to low. So if they ask you for the terms in descending order, we're going from high to low. If it says ascending, what does that mean? Low to high. But standard form is always descending order. High to low for the exponents. Okay, this is asking for descending order in standard form. Okay, now, this one says, explain whether it's ascending, descending, or neither. What about this one? Descending. What about this one? And this one? Neither, because that's a 1 there. Okay? Now, notice here they're saying combine the terms and arrange in descending order for the variable p. They will have to give you which variable down here, because you can't do it for n and for p. Do you understand? So we combine our like terms. Sorry, let me jump down there. We combine our like terms, and then we put them in order for the p variable. So the biggest p is this one. That would be written first. This next smaller one is this. And then we've got p to the second, and then we have p to the first. Okay? They would have to tell you what variable it should be. Now, very quickly, last thing that they're going to be asking you is to evaluate. Focus yourself here. Substitute in. Evaluate means find the value down to one number. Be careful. Make sure you are using your order of operations. The majority of the mistakes that happen are with 5 minus 2. They do that first instead of the exponent. Remember, it's 2 to the 4th is 16. So it's really 5 minus 16. Pay close attention to this section, because you will learn all these fancy processes with the quadratic formula, but if you don't know your order of operations, you're going to get everything wrong second semester. All right, that's the lesson. Sorry it took so long.